So, welcome back from the break. Please welcome Eric, a long-time true person in the IPv6 Summit veteran. So I'm really happy that you are here and looking forward to your presentation. So the stage is yours.
Thank you, Chris. So, thank you. I don't like too much the way you say veterans, right? I'm still not on a wheelchair, but it's okay, right?
Well.
And you notice that I am using the old logo and not the new logo from Eno, so must be a real old timer. So I'm based in Belgium, right, for those who don't know me, and I'm working for 2-3 years now from the Paris Innovation and Research Lab, based in Paris, obviously, where part of the team focus on what can we do in an IPv6 only environment. You know, IPv6 is different because we can have multiple IPv6 addresses per interface, we have zillions of v6 addresses, and we have extension headers. So we've got projects working on this, and one of the projects is here when we have multiple v6 addresses per interface. Because I guess when you look about the title of the talk, you understand, of course, security, privacy, and IPv6, but what's in the middle? Most probably you wonder what's inside, right? And you can guess somehow. Anyway, I will explain this, but first, let's talk about transition. And to come back to the veteran parts of the introduction by Chris, this was my first car, Peugeot 205, so years ago. Now, what I'm doing is a Cessna, which is not mine, right? It's rented. And any pilot in the room? No? So just a few things. We are used about codes and addresses. KHAF. This is the airplane civil aviation code for an airport, always 4 letters. And K stands for US. Pretty much all airports in Germany start with ED. Okay? And then 2 other letters. It's not for pilots, it's not Merck, it's not FRA or whatever. We are using 4 letters because there are way more airports than commercial airplane going there. Anyway, talking about addresses, I started with DECnet, right? Maybe I know you knew about DECnet. You are younger than me, but maybe.
Even for me, DECnet is
a thing of the past. Thank you. Okay, I need a wheelchair now. And okay, and there were also already a mapping between the DECnet address and the Ethernet address, right? The blue part is the blue part, area, and the node. Now, of course, we are doing in v6, and we've got v6 addresses, and as well, there is a mapping between part of the v6 address to the solicited multicast address to the Ethernet solicited multicast address as well. So, kind of thing, right? Took me 85 hours to learn flying, and it took us many, many years, and we are still not yet there, right? The beauty, we're still learning, and at least in my case, still having fun. All of this, whether you fly, you drive, or you simply do network designs, you must do it securely, right? This is really, really important. Agenda. I will briefly describe what I'm trying to solve with this multi-prefix stuff and introduce the technologies. And then, of course, the most important stuff is the potential attacks and how we can secure them and mitigate the attacks in what we call PVD, provisioning domain, I will explain what is it, and Seder, source address dependent routing. And again, I will explain what is it. And then I will finish with some other topics, which are not related to the talk, but are related to v6. So this session is about new technologies currently being developed, right, at the IETF. It's still under development. A few things can be changed. There are nearly no products available right now. And one of the reasons to present to you today is not only to attend the week, but your comments will be really, really welcome. Okay? So problem statement. Nowadays, PC, laptops, phones do not have a single interface. This PC has an interface maybe over Wi-Fi or Bluetooth to a phone, which is tethering, right, to the mobile provider. He has a wireless connected to the network, and is a wired connection. At least 3 interfaces. On the Wi-Fi and wired, it can have 2 connectivity because it's multi-home, ISP1, ISP2. And it can have as well a corporate VPN. starting an IPsec tunnel to another place. So basically, he has 3 interfaces and 4 providers, right? The mobile, ISP1, ISP2, and the corporate VPN. It's no more one interface, one IP address, right? This is the reality. So how does it work? And sorry, I will be a very bad guy. I will pronounce the word starting with an N in an IPv6 conference. So let's say I have selected this interface, and I'm using RSC 1918 addresses, right? We are in IPv4 legacy world in this case, and I want to go via ISP2. So my route by default to exit is through this edge router using address 2. How I'm doing it? To ensure the traffic is coming back there, I'm using NAT, and the N word. So now, if you move this to v6, and you want to be multi-homed, multi-interface, you don't do NAT in IPv6, right? You should not. I mean, there are devices doing it, but it's very stupid to do it. So how you will do it? In IPv6, every providers, the 4 providers, will assign you a single prefix, right? They will be sending you arrays with PIO, prefix information option, into the arrays, the route advertisement, for each of those addresses. This is what I say native to IPv6, right? The IRC 4861. If you're using a small end home network, you may want to use Home Network Control Protocol, HNCP, which is not really well deployed. But it's basically something like to distribute a prefix that you have received. But anyway, you will receive multiple of them. If you are a big enterprise, I mean, you're the Cisco of the world, or the, I guess, yeah, NW as well, or BMW, or whatever, you do BGP with your provider, and you announce small prefixes out of your range. Perfectly fine, it works. But if you are SMB, having 2-3 routers, 2-3 buildings, you cannot really do BGP, right? You need to be in our Cisco device, CCIE, to understand what BGP means. So you need to find something else. And how can you do the address selection? There is an RSC that describes, oh, I want to talk to this destination address. I've got those addresses as a source. Which one am I selecting? Of course, the one with the longest match, right, with the destination. That's the goal. But you also have some protocol like multipass TCP, which is becoming more and more important because they exploit the fact that you have multiple interfaces to send traffic in all directions at the same time, increasing the bandwidth, right? So things are getting complex. And we got issue now as well. 3 interfaces, 4 addresses. And this is an issue with a slide coming from the IETF 99 by Ted Lemon. He says, hey, you know how CDN, Content Delivery Networking, works, right? The Akamai, the Cloudflare. They basically base on your IP address when you request a fully qualified domain name translation by the DNS. They give you the IP address which is closest to the resolver. Okay? So now, I'm here in Germany. My phone has got an IP address which is in Belgium, right? This is how 3G, 4G works. But the Wi-Fi, I got an address which is based in Germany. Now, what if I do the DNS resolution using my source address, which is the Wi-Fi? Of course, then Akamai and Cloudflare will give me, oh, you want to go to this newspaper? Please use the cache which is here in Heidelberg. But then my browser actually uses the cellular connection with my IP address from Belgium. So I'm traveling to Brussels, exit to the internet in Brussels, and come back to Heidelberg. It works, but it's not optimum. Okay, that's one point. Another point is from the guy, and you were talking about him and just before, Marcus Keene. At that point of time, he was working in Microsoft. Now he works at Amazon. But the problem is the self. In this case, they want to do what they call local breakout. And in Microsoft, they got a prefixes per continent. So Erin in US and RIPE in Europe. So this green stuff, it's the European prefix. Okay? And the corporate network in North America from Microsoft is another prefix coming from Erin. Okay, so obviously all the branches, which are here at the bottom, receive a prefix coming from the European prefix, which is the green address, right? They receive it by array or DHCP. Now, they want to have as well local breakout without doing BGP. So they go to an ISP, DB8 here, the blue, and they receive a prefix and they also distribute it. Okay? So all Geneva PC now has got the green from Microsoft and the blue from the ISP. Really nice. Now the thing, Microsoft Azure, the cloud, is using the ARIN, on the European, prefix. Okay, so now, what am I doing? My client's got two addresses. He wants to talk to Azure. Longest match will be the green address, right? Because he received it from the corporate VPN. So it will be going there. Packets will be routed there and there because they want to go there, right? So the default route is to the internet. But this guy will drop the packets. BCP38, right? This is your Twitter handle. Oh, this is the bad guy, which is dropping the packets. Yeah, I mean, no, in good guy in this case, right? But you're breaking the scheme at least. And now, if you want to go to a website, an email server, which is in US, from this European, the longest match now is no more the green, but it's the blue. So you will go this way and try to enter back by the firewall, will be blocked. Okay? So something is wrong there. If you do BGP routing, it's fine, right? You don't get this issue. But they don't want to do it. Or the same thing if you have a typical PC, and this is basically what I have at home. I receive one prefix from my service provider and one prefix from the VPN to Cisco. So now I'm pretty sure that when I need to talk to something which is there, I need to use the right address. Okay? And not the wrong one, else I will be something wrong. Okay, so this is where it comes, the draft. Yet I am writing with Pierre Fitzer from Cisco as well, and Tommy Pauly and David Schnazi from Apple, because we need to fix this. And it's about what we call provisioning domain. And as I said, it's -01, right? So it's not fully baked right now. So how can we give enough information to a host and to application in order to select the right source address? That's the point I want to solve here. There is already a concept existing about what you call provisioning domain, PVDs. That's basically the bundle of all network configuration items. The address, the next hop, the DNS search list, the DNS server, and so on. And the interface, of course. All of this, that's a PVD. In IPv4 signal interface, you have only one. In IPv6, you have at least one per interface. You have multiple interfaces. And you can have multiple provisioning domain per interface, because you can get multiple v6 addresses, right, in v6 per interface, in different prefixes. That's the point. And we extend in this draft the PVD with application-related information, such as if you use this address, there will be a captive portal. So be ready to present to the user a user element password challenge, which would be helpful for an IoT device, because an IoT device typically doesn't have a way to traverse captive portal. So no point of using this address. Okay? And other stuff. And human readable names. How do we do it? How can we make this bundle as a one thing and give it a name? We use a new extension into the route advertisement, and we just received the type this week, yesterday, so we are happy, from the IANA. What's inside? That's typically the way IETF describes an option, right? We have the PVD ID, fully qualified domain name. We identify this set of information by a fully qualified domain name. So, for instance, example.org or corporate.example.com or something like that. which is human readable, and then it will allow the application to select this PVD or this PVD. Okay? And once you select it, you keep using this DNS server, this next stop, this address all the time. And of course, you can select another one. But it can be done at the application, at the process level, or at the thread level. It really depends upon you, the way you incorporate it into the kernel. I'm skipping many details right here because it's a security talk. Just one flag, the H. H stands for HTTP in this case. It will allow us to retrieve additional application-oriented information over HTTPS. Not always the case. That's the reason why there is a flag. So when a laptop, a mobile phone, or whatever receive a router advertisement with this option and this flag, it will basically do this. So you receive from the router advertisement with the PVD. What it's doing, you get the PVD ID, which is used for the application to select the right set of parameters, but it's a fully qualified domain name. So now I'm building a URI, https thecorporate.example.org /.wellknown /PVD. I'm connecting now to this server over TLS and download a JSON file giving me application-oriented information, such as DNS search list or some security information, or whether it's a captive portal or whatever. For instance, in this one, this is an example. This is the bare minimum JSON file with the name and expiration. So at that point of time, you retrieve it because it can change. The set of prefixes that are covered by this PVD, and I will come back on this. They are really typically very large prefixes, 48 or 30 or whatever. And DNS zone, in this case, it means that if you want to reach anything in example.com or subexample.com, please use this PVD. Okay, don't use another one, like intranet.example.org, for instance. Okay, use this one because it's advertised by the VPN. And you can get other example like captive portal, and I will come back on captive portal. This is the URL when you need to go. And no internet through, that's a walled garden, meaning that's only used, for instance, for VOD, video on demand. Okay, so you can download movie, but you can go to the internet. Talking about captive portal, I mean, nobody likes them, to be honest, as a user, but it's mandatory sometimes. The way it's done right now, there is an HTTP redirect, right? HTTP requests are redirected. Now, if you put Google or Facebook as your home page, it does not redirect anymore. Your browser, like Chrome or Firefox, will refuse to display them. HSTS, right? Certificate pinning. You need to be a certificate which is there, not a self-signed certificate or whatever. No way. So not working. There's a reason why more and more operating systems and go to some very specific URL to see whether there is something in the path. There's a reason why on some machine you get a pop-up, right? If they cannot go there, they pop up a window. That's not always work. And in some case, like airport, when it's not free, or some station, they are on the same hotspot Wi-Fi, 2 or 3 providers, 2 or 3 ways of paying. For instance, Deutsche Telekom or Proximus in my case, but also worldwide roaming like iPass, that's what we are using internally in Cisco, and Boingo, for instance. So you have a screen with, and select this in the drop-down, this partner, and then different ways of authenticating. Yeah, not easy, right? But doable. But you need to be basically engineer, right? Not sure whether your brother or your sister can do it. With PVDs, we can have now 1 PVD per provider. So single access point, single Wi-Fi, but they are sending 1 PVD for Deutsche Telekom, 1 PVD, let's say, for the train station, Deutsche Bahn, and 1 PVD for Boingo, and 1 PVD for iPass. You receive 4 arrays, okay, with 4 different URL for the portal. And as we have, if you see in the previous slide, the URL in the PVD, oh, I'm selecting Boingo because I see 4 on my screen. I'm selecting Boingo. I'm using the Boingo source address, going to the Boingo captive portal, enter my user ID there, and on we go. And the other one I ignore. There's one way of solving the captive portal. Implementation status. We have been working on this on Linux, so we got implementation running in Linux. It's obviously on the GitHub. We modified the IP route to display and understand PVD concept. We have a Wireshark dissector, so we can display what's inside. And we modified 2 array advertisement daemon, the one mostly used, array DVD, route advertisement daemon, and ODHCP, which is basically using on OpenWRT or LED, small routers. And basically, if you wonder, the one commercial vendor is based in San Jose, and name starts with a C, right? I'm paying my salary. So the other part now, with the PVD, we were able to give enough information to the host or the application to select the right source address, which is already a good thing. But now, we still need now the network to behave differently based on this source address and route packets not only to the destination, but also based on the source. You need to go that way or that way. That's what we say. Forwarding based on the source address and not only on the destination address. So for the routing people in the room, be ready, right? It will be shaky. So that's what we call source scoped forwarding information-based entries. And there is another draft on this. And this one is much more mature, by the way. And David Lampner is a German guy, very brilliant. So Seder, source address dependent routing, because we do routing based on the source. In a nutshell, FIB, that's really the forwarding information base, right? This is when the router takes a decision to forward packet there from this interface is based on the FIB. This is really the cornerstone. All FIB entries are extended by adding a source prefix. Currently, all FIB entries are this destination, this next hop, this interface. Now we say this source, this destination, this next hop, this interface. And of course, we use : /0 when there is no source-specific information. Okay? So assume that everything that you have done right now are extended by this : /0. So this is described in this draft. And now basically the routing is done on the best match between the source address of the packet, the destination address of the packet, and the FIB entries, assuming that we prefer the match with the longest match on the source. Okay? If you want to do it, this is explanation by Pierre. This is explanation basically in the draft. So we start with the source prefix, right? And we do what are the longest match on the destination. This is the potential routes, because you can get multiple of them, right? Or 0. Now, you do the longest match on the source of all those routes. Let's say you get 3 potential routes. You look at the longest match based on the source. If you find something, then you use it. If not found, you start again there with a shorter prefix. Okay, source prefix. And eventually you will end up with a : /0, and it will be a match, obviously, if you have a default route. Okay, this is of course pretty dumb, because you may end up doing this loop 128, obviously, which is not very efficient. And obviously there are other implementations, but it's very easy to explain this one. Example. This is the extended FIB entries, right? Seder FIB. Source, destination, and next hop. If the source is any, destination is any, you use router 3. If it's DB8/32, okay, destination is any, router 3. But, red line, if I am using this : 2/64 as a source, destination is still any, now I'm using router 4. Okay? So now packets coming with this address, which match only the second line to the destination we don't care, will be done by router 3. But if we have a more specific address, which is covered by the red one, the longest match is this one on the source, the addition match, we are using router 4. So you may tell me it looks like policy-based routing, as we say in the Cisco land, but policy-based routing is not so efficient. It's much more flexible, right? Because you can do it with access control lists and the application level as well. This one is only on the routing, on the addresses. It's much more efficient. And we can link it to OSPF or BGP, right? Because we are extending as well OSPF, ISIS to handle Seder route information. So look about this now. We've got the client here, 2 ISP in a small enterprise. And typically small enterprises got 2 uplinks. One 4G, for instance, and one DSL or cable, just in case. You can, at the first time, implement Seder only at the exit router, like router 3. Okay. And now, if somebody is using the source address from prefix 2, coming from this second ISP, the next stop is not this ISP1, the next stop is this one. Okay. So now packets will go that way, if they are using a source prefix 2. Okay? Solving the multi-homing very easily, no NAT involved, right? We were doing with NAT in IPv4, and very simple. And we'll get demonstration of this, by the way, because code is running. Summary here, right? So we want to do routing based on the source, because in IPv6 you can get multiple source address per interface. Okay, this is what we are working on. I skip the details, right? Because now I want to focus for half an hour, basically, on the security of it. So, this is a summary, we don't care. What about security? Raw PVD. How much can an application or a host believe in the information which inside in the PVD? Because now we may much more information. We put application information, such as which DNS zone we need to connect to. Is it a captive portal or whatever? We intend, for instance, to put some bandwidth and some quality QoS information there. And what are the confidentiality and privacy issue? And this is basically where I'm leaving on Thursday morning, so anytime, provide me feedback, it will be welcome, right? It's the reason why I'm coming here. So confidentiality of the JSON file, because basically we know how to build the address. We're always using .wellknown/pvd. It's a well-known URL. The only thing that's changing is the pvd name.example.org, but you can guess them, right? Most probably cisco.com, you know, ERNW.de and troopers.de and this kind of stuff. Okay. It's a well-known URL, so it's guessable. That was my point. How to provide confidentiality to it? One point, of course, do not put anything which is confidential here. I mean, just beware, right? So that's my point. And the HTTPS server saving this JSON file should only accept requests coming from your prefix. If, let's say, in 2 years, troopers.de /wellknown/pvd exist, they should serve the information only coming, requests coming only from this troopers network, not from others. Kind of easy. But again, don't put anything else. Now, the rogue PVD, or spoofing the PVD ID, is more challenging, right? So, repeat as a route advertisement, sending PVD, advertising good.org, for instance, fetching over HTTP/TLS, the JSON file. We don't use send, secure neighbor discovery, right? It's dead from a long time. But now, the first operator can be rogue, the network can be rogue, the server can be rogue, right? That's the approach I'm taking here. And that's what we define in the draft. Okay. Obviously, you have seen the black hat, right? It's a bad guy. We have here a Wi-Fi access point or a share switch. This is the naive victim, this is the bad guy, and the rest of the network, right, is unchanged. Obviously, the bad guy can advertise when you are in a Starbucks or any kind of open hotspot, can advertise a PVD containing good.com. is a Bedguy, right? You can send it. In this case, it's easy, right? We are in 2018. I would assume that all switches and all access points can implement array guard and drop the array. Easy. Now, the Bedguy owns the first router. You go in a coffee shop, in a bar or whatever, and you receive an advertisement coming from your company or from, let's say, something that you trust. So this guy is still sending PVD, good, put it in red because that's a wrong one. He set the flag to H, and PIO, prefix information option, okay? He advertised its own addresses, which are bad, easy to recognize. So now, the laptop is fetching the JSON file. And he got this JSON file. But this one is a fake server as well, right? So it doesn't have the certificate because he wants to serve the right one. It doesn't have the right certificate. The SSL session doesn't even established. And this guy untrusts the PVD. And you need to configure them, of course, to say H flag only accept PVD having the security option, the H flag. Okay. You configure the end host to say, if I receive a PVD without the H flag, I don't consider them. Pretty much like you configure some browser, only go to HTTPS site. Okay, that's one attack. So now, the server is the right one. Same thing, I'm advertising the wrong router advertisement. There is a H flag, I'm going there, and then this time I receive indeed the name, the TLS session is established because it's the real server, not cheating. But the prefixes, there is an element which is mandatory into the JSON that is the set of all prefixes belonging to this PVD. And in this case, this is beef. Okay. So the PC receive it, and then, oh, the PIO I receive, bad, is not part of this prefix. I'm wrong. The prefix I receive in the array does not match the one I receive of HTTPS. Something is wrong. Do not trust. Do not present to the user. What can we do now? So, Bedguy is using an IPv6, right? And that is bad, we all know it. So now, he's still using advertising the good name, and now he's using in his PVD, the PIO, the prefix information, the beef, the right addresses. It's no more bad, he advertised. He advertised the v6 addresses from the good company. And they do, not TP, PT, translation between the good addresses and the bad addresses. The bad addresses are the one he received, the attacker received from his ISP. So now everything is going fine, looks there. In order to receive the right JSON file with the right prefixes, now, ooh, this server now receives a connection coming from an address which is bad, not the beef one. So he should refuse it. He should refuse to serve the JSON. Okay? So connection is closed, not even established, right, if you use an access control list at the network layer. And then this one cannot connect, do not trust. So the only case where you can bypass and send a PVD, as far as I know and we know and the other, is this case. The attacker has a foothold on the GoodComm company. He has physical access to a network managed, operated in this PVD. So now, he receives a real array with the GoodComm and the right prefix. This is the attacker. He owns this router, right? Hotspot or whatever. He established a tunnel, IPv6 over whatever, v4, TLS, whatever you want. You don't care. And he starts sending now wrong PVD with indeed the beef, the right addresses, the good.com and the flag. So now the PC receives it. oh, there is HFLAC, then I'm going basically to good.com/well-known-pvd to fetch the JSON file. And how does it go? It's a bit complex. So it's going inside the tunnel, right? Because there's a default route. This guy follows the default route inside the tunnel to the Bedguy, where it decapsulates. Source address is beef, because that's the address of the guy, and simply send it a normal routing to there. This guy will serve it, because it's coming from a real beef address, which has simply been forwarded there. This guy will match the prefix from the JSON file. All right, this is the beef. It says beef. Everything is fine. That's a thing, really convoluted, but that's one way of bypassing the kind of security we try to put there. So everything appears good to the PVD and the host, but it requires somebody inside the right PVD, right? So you can, for instance, get this in starbucks.com, and if you go another place, it will appear starbucks.com. In this case, that's easy. If you want to say cisco.com, for instance, you need to be in the network. So good luck, right? I mean, if you're able to penetrate the network, we have other problem than this. That's basically it. Again, you, Gabriel.
Yeah, don't have to intercept TLS, so
No. And you don't have to intercept the TLS, because TLS session is going from there to there. This guy doesn't see it, doesn't care.
I just forwards on the...
Exactly, yeah. That's a good point. So, other point, privacy. That's important as well, right? So now, sure.
Why does the return traffic also go to the attacker?
Because simply the address, it needs to fake here and do proxy NDP. Yeah. So basically, the address, of course, will be routed to this router, and this guy will do proxy NDP, and then he can do some cheating. Yeah, it's not so easy, let's say, to do it, but it's doable. I mean, I think everyone in this room could do it, assuming you have a foothold there. And if you have a foothold there, you have other problem anyway. So, and you can do it without PVD as well, right? Simply by doing remove PVD of the equation, you get back to square one. Okay, privacy. So each host now fetch this JSON file. Okay, he boots, he got an IP array, which doesn't know, he fetch the JSON file. So it means that the HTTPS server serving the JSON file will know all the v6 addresses of all the hosts connecting to him. He can log this, right? So you have some privacy issue, right? Because he knows where you are and which address you are. He doesn't know who you are really, but he knows your v6 address. He can collect all of those. And specifically now we're using still the EU64 with always the same address, so you are really in bad shape. But if you don't like this, and some people do not like this too much, the host, and that's what you write in the draft, should change your v6 addresses as soon as you got the JSON file. So it generate address 1, fetch the JSON file, got it, generate address 2, deprecate address 1, and use address 2. Then, of course, you are fine. Now, the HTTPS server obviously belongs to the organization, is operated by the organization sending the PVD. Okay, so there's a network operator typically, or something close to it. So he knows anyway that you are there, because he has access to the NDP cache of your router. He mostly has radius information or captive portal information, and so on. Okay, so back to square one, right? You know, and isn't it better to detect captive portal by this way, so within the network, than going to this URL, which belongs to Microsoft or to Google or to Apple, which is not operating your network, right? All of us. I mean, in my case, it's Android, so I'm going to something like this for Google, so Google knows where an IPv6 address is alive, okay? My iOS iPad is going to this address, right? Simply replace example by Apple here, right? And you got it. So Apple knows that my v6 address on my iPad is alive. So that's even worse, because in this case of PVD, you keep the information, the privacy information, within the operating domain of the PVD. Nobody knows. Nobody else knows. In this case, somebody else knows, which is, I don't think it's nice. So I would say PVD with additional information, so the JSON file, is not that bad. That's my point of view. But I mean, security is never 100% anyway. There is always a balance between security and simplicity. We want to keep it simple. Things that are too complex are not always secure. And anyway, in the current deployment and standards, you need to trust somehow the first device, okay? Even with ArrayGuard and all we can think you want to do. Okay, that was for the PVD, right? How the application select the right address. Now, what about Seder? The address based on the source and destination and not only on the destination. First thing, they could be kind of a DOS. As I said, there are some implementation, and the first time we did an implementation in the source code was basically very naive. That was the algorithm, right? So going through old mask and something, and we were going sometimes like more than 200 performance hits. So if we were able to route 100 meg per second, with tuning Seder with bad implementation, we were only able to forward something like 0.5 megabit per second, which is of course not acceptable, but the naive implementation can do it. So what if somebody knowing that your network is using a bad implementation of Seder, you are sending packets with the source and destination, maybe they will go nowhere, you don't care, but the performance of the router will drop because it's spending much time in hardware or software for doing the bad implementation. Mitigation, obviously use the right implementation, right? And I mean, this is more for reference to be complete, because I guess there will be no bad implementation on the market, I hope. So now, look about this. So we have a client C, a router R1, R2, a server S, and we are the good guy for now, a specific security device. Like, if you believe in this, an IPS system. On the router tree, my Seder FIB says from any source to S, the server, next up is R2. Okay? And then all the traffic goes that way. Now, something strange is happening either on the server or on the client. And I want to be able to see what's happening there. But those things are in US, let's say, and I am here in Heidelberg. So there is a very easy way now to send via OSPF or some orchestration system, you don't really care, a specific Seder route telling, hey, for client C to server S, now the next stop is this device. Now all the traffic is going that way. Okay? So you can do there, simply inspect the traffic, or if this guy is launching a DOS somewhere, you simply drop the packets here, or you simply say, from any client to any destination via the null interface. Okay? Pretty easy to do it. That's another way of doing remote triggering black hole, for instance, without BGP. And you can do it anywhere in the network. Now, if you don't secure your OSPF, your ISIS, now this could be a bad guy, okay, and it can intercept the traffic on one specific host. That's, of course, the flip side. But now, even without Seder forwarding, if the bad guy is able to send a route, hey, server S is by me, you will get all the traffic from all the devices. So you're basically receiving a traffic, and you can do interception as well. So I don't consider this as too bad. This is basically what I said as well here. The routing protocol, the IGP, needs to be secure, right? There are ways of securing OSPF, ISIS, and BGP. So just a reminder, this session was basically about technologies being drafted at the IETF. So we got implementation, but not really shipping. And again, through press comment, I'm more than welcome, right? In the next minute, end of the today, during the dinner, tomorrow, or over email. Sincerely, right? I don't appear as the guy knowing everything. I think there are more in 10 heads or 15 heads than in only one. So please. Other topics. It's nothing to do with what I said before, but still thinking about IPv6 and security. Read this. So it's a real email, and I got the permission from Glenn to make it public, right? So the IETF was under attack. And by 26,000 hosts, 10,000 of them were using IPv6, 1/3. So it was a bad news, right, to be under attack. But you end up, and again, I'm not modifying the email, hooray for our site. We made it, right? We are under attack by V6. I mean, when in 2012, when Cisco.com went over V6, at some point of time, hey, we detected through NetFlow an IPv6 denial of service attack. Oh, wow. And we typically now receive DOS about 10 gigs or 100 gigs. At that point of time, it was 10 meg of IPv6 traffic. But it was a DOS, right? Now, I mean, we receive real IPv6 DOS attack. But this one is nice. I keep hearing that NAT means security. With NAT, if my webcam is behind the NAT at home, V4, right, Mirai or whatever cannot find it. But a friend of mine, Steintor Bjarnason, which now works in Arbor, presented a paper last summer of a blended threat. And we will get the slide, by the way, where it was, the thread was a PC malware or Windows malware. So downloaded by clicking on the wrong link, installed on the Windows machine, and then launching Mirai behind the NAT. Which is, I mean, kind of cool somehow, right? It's smart. It's bad, right? Don't take me wrong. But it also proved that NAT does not protect you. So think about it, right? NAT does not protect you. Other point, I went twice in the last month to Europol in The Hague, basically because they're facing an issue, of course, with CGN, Care Great NAT, and Bedguy hiding behind. Okay, I got many lengthy discussion on this, and that's perfect discussion tonight after a couple of beers or a glass of wine. Or I should have talked about it yesterday at 9 p.m. Okay. Because some people say privacy is nice because if I'm downloading by BitTorrent or whatever, I don't want to receive a letter from a lawyer, a US lawyer, right? I can understand this. Now, when you talk about Europol, right, we don't talk about copyright infringement. We talk about pedophilia, child pornography, terrorist attack. And then, honestly, and we are basically in democracy as well, so you want to find something. And in the statement, if you look upon this, you will see there was a supposed temporary thing, CGN, but it's not the case so much. And IPv6 takes longer to be deployed, and we see much more deployment. And as you said, I know Europe and US are leading, and India as well. So trying to present that and convince that IPv6 is important, but not enough. Yes?
I've been wondering why is that, because I would say in case you operate CGN as an ISP, you need to be able to give the authorities the identity if requested.
Of course, yeah.
And then, as an ISP, you should not record only the IP, but also the port, to be able to find the customer behind it.
Absolutely, and you're right. So the intent of the beginning was CGN, there was even an RFC, there's I think some law even in most of the countries to log. This user was at that point of time using this port, and bingo. Those logs from ISP are most probably synchronized, touching wood, with NTP, not always. Now, if you go to Facebook, for instance, to take an example, right? And you take, hey, at that point of time, I mean, this page was something which is about child pornography or whatever, right? Or racist comment, or something which is illegal in your country. Facebook will give you the address, not the port. Okay? And in some case, I guess Facebook is also synchronized by NTP, but if it's a comment on a newspaper, the log file will not be synchronized by NTP. real story. And now, if you go to one very specific, let's say, child pornography website, which only exists in one specific v4 address, and in your translation, because the ISP logs the source and destination, right, you will see only one guy going to this address. Then you know who is it. But if it's like a Facebook, where out of your, I don't know, 1,000 connections, 500 of them are going to Facebook, it doesn't help, right? Good question.
And also which NTP, because when we say NTP, we say it's fine, I have the same time in my network. But if you go across networks, it can be different NTP servers. And these logs at the carrier grade net is really fast.
Yeah.
It's unbelievably fast.
I mean,
Yeah.
and yeah, I was about to say something, but I forgot about. Anyway, so something I heard there, because a few things will be anonymous here, right? But I think it's important. One mobile provider in a big European countries is sharing one IPv4 address for 10,000 subscribers. Okay, so maybe there are 9,000 of them going to Facebook at the same time. Good luck. Okay, another ISP in Baltic countries, right? You know those 3 countries where at least me, I don't know exactly, I know where they are, but I don't know exactly which one is which one. Is basically sharing one public IPv4 address, mostly for all its subscribers, for more than 100,000. Right. And as I said, law enforcement agencies knows about this destination and source port logging, but in some cases, basically, do not log the source port or even the destination. Because if you ask Facebook or Google or whatever, they got their own CDN. Okay, so you can be served from Heidelberg, Munich, or Frankfurt, but you don't know which address the bad guy has used. You only know the bad guy address. So you need to remember as well the translation for the CDN. Right? So you end up with a complete mess. And basically you are talking there, they were talking example about child pornography, about people, I mean, murder, that were unable to solve. Okay, so that's really impacting. And then it makes me laugh. A big ISP, again, right? So you know the name for sure. That's what you call an incumbent, right? And it was with InfoSec guy. He claimed to me, oh, IPv6 anyway is more secure than IPv4 because it always uses IPsec. And it was 3 weeks ago. Okay, 3 weeks ago. Okay, anyway.
Probably was never here.
No, it's not here, right? And now I presented this graph, this slide, sorry, which basically says, okay, we need to move to IPv6, right? And that was my point, but it's not always enough. Look about this table. So whether the client is IPv4 only, v6 only, or is dual stack, and whether the server is IPv4 only, IPv6 only, I don't know about many of them, or the server is dual stack. Obviously, if the client, first row, is IPv4 only, and you're going to a server which is v4 only, CGN, bad luck. IPv4 only, going to a v6 only, no communication, right? So it doesn't exist. And IPv4 only, going to a dual stack, you use IPv4, right? Now, if your client is dual stack, which is most of the same for ADSL and cable, right? If you go to a v4 only, this is the last row. If you go to IPv4 only server, of course you will use IPv4, so CGN again. Now, if you go dual stack and you go to a server which is v6 only, it works, right? You get a unique ID per user because you can only use v6. Now, if you are dual stack and you're going to a dual stack, you know API ball. You may end up using IPv4 or IPv6. API ball will give you small preferences for v6, but there is no guarantee that it will use v6. If it's use v6, you need a unique ID. And guess what? If you're a hacker or a bad guy, you disable v6 in this case, right, on your client. You only use IPv4 to go back this line. So having a dual stack client does not help. The only thing where you can get a unique identification when you are IPv6 only like some mobile provider, like in India, like Reliance or the Verizon or the T-Mobile in US, where you have v6 only, and you're going to a v6 only server or to a dual stack server, because then you're using v6, right? You have no choice. But again, don't forget this, right? VPN, Tor network, open relays are still there over v6. So the bad guy that wants to escape the police can also always do. We are only catching there the stupid guy. Okay. This was my main message here. A friend of mine told me yesterday that this word is wrong. It's not user, it's subscriber, right? For instance, at home, I got the subscription is my place, but I got a wife and 2 kids. Plus, I mean, devices, right? So that's identifying me, the paying customer. Okay, just to finish, I am working on for many years now on a draft which is about operational security consideration for v6 network. And as we are in Troopers, we have a new author, which is Enno, right? So thank you again for doing it. He provided us with hundreds of review comments, hundreds of suggestions. So the text is much better now with this. Okay. Conclusion. v6 is changing. As you said, this IPv6 is different. I mean, it's not that different, but it's different. Typically, you have multiple v6 addresses per interface, multiple interface. So we've got PVDs. We try in the draft to make it simple for the application, efficient, and provide enough of security on it. Seder, the source address dependent routing, it's needed for an easy multi-homing situation. We believe that we understand the security issue, but again, please tell me. And there are way more IPv6 only innovation coming. Okay, so be ready. That's many projects. Okay, any question? Yeah.
You have the option of using HTTPS. Why didn't you choose DNS and DNSSEC for this? That would make it more easy to distribute and put it closer to the routers and the clients.
Yeah, that's a serious discussion. We could provide the JSON file as well in a TXT record, for instance. That's one way of doing it. The main reason using HTTPS is that it's simple to do. And DNSSEC, if you don't forget, right, DNSSEC is either you ask a recursive server which is doing the DNSSEC and you trust the recursive server, or you do it on your host. And I know about no implementation of DNSSEC native on Windows, on Linux maybe, oh yeah, with Bind of course, on Windows, iOS, and Android. So DNSSEC, yes, if you trust the recursive DNS server. Done. I can be wrong, right? But I would love, that's the reason why I'm here.
But if you have that advanced client that does these requests, you could just link in the DNSSEC part.
Yeah.
And the thing is that I don't think HTTPS is simple because it's difficult to distribute it, because then you have to distribute the certificates and the private keys and so on multiple sites, where DNSSEC would enable you to just distribute it anywhere.
We still have the discussion, to be honest, on this, and thanks for the comment, with people from Google, by the way. Distributing the private key, if you see a look about the Cloudflare and the Akamai are doing, our own website is hosted by Akamai, Cloudflare, sorry, and you can SSL to all of those caches. So there are techniques for doing it. It needs to be orchestrated, right? For sure, but if you're using PVD like a big organization, most probably you know how to do it. But things are still open. And the big hurdle for DNSSEC is really the lack of implementation. Yeah.
Do you really think that PVD will be used one day? Because from a rough overview, it looks really complicated, and you have to make implementation on several operating systems and all applications and all this stuff?
That's a fair comment. So PVDs, you see the authors, right? So you get basically a network vendor doing the implementation. We are doing the Linux implementation. The 2 other authors are from Apple. And basically, in the hackathon in the ITF, one IETF ago. Tommy was there. It's a brilliant guy, right? In one day it was coded in iOS. It's not shipping, right? Don't take me wrong, but in one day it was coded. The other author now was Marcus Keane from Microsoft. He moved to Amazon, so he asked us to remove his name, but the -00 was Microsoft. And we are talking with people from Google for Android. I mean, the guy developing the OS stack.
Okay,
so I would say, honestly, yes, I believe in this.
Okay, so it's about the implementation part, and how about the operational burden?
So the operational burden, it's up to you, right? You're not forced to use it. But captive portals, it's already a burden to do it. And in the case of the router sending it, it's typically one line of comment. So that's not a big deal. If you have one PVD, that's one additional line. We were talking about CLI, right, yesterday. It's simply one line of CLI to send the PVD name, and that's it. Yeah, I mean, you don't have nothing for free, right? If you want to provide some additional stuff, if you want to do something like QoS or security VPN, yeah, it takes. This thing is way simpler, I think. And if you look about the way to do it with multi-homing, that's the easy way to do it.
Yeah, thanks.
Welcome.
So, thank you very much, Eric, for your insights. I think the PVD topic has the potential for more further discussions, so I would suggest we postpone it for the dinner tonight. So, thank you very much again.
Welcome.
Really enjoyed your presentation.
Thank you.